It's mid-morning and you walk outside to get a breath of fresh air and admire your beautiful lawn. Suddenly you hear a noise from above. What could it be? Is it a bird? Is it a plane? Oh wait, yeah, it was just a bird. You take note of the two most prominent colors overhead, the blue sky and the yellow sun. As you turn to walk inside, it occurs to you that you've always known the sky is blue, but are also keenly aware of the fact that you're not exactly sure why that is. You plop down on your couch, iPad in hand, and head to nosyuniverse.com, where you find this exact video. Nice, right? A little bit Inception, a little bit... Anyway, from space, the sky is black and the sun is white. But from Earth, those aren't the colors you see. The sky is blue and the sun is yellow, except when it's not. At nighttime, the sky is black. And during the morning and evening times, both the sky and the sun take on a reddish-orange color. But why is that? Why the different colors? Why is the sky blue? When you're looking up at the sky, you're seeing a mixture of all scattered colors, which are mainly green and blue, giving the sky that pale blue look. If you glance toward the sun, the colors that were not scattered away, the reds and yellows, are directly visible, which gives the sun a slightly yellowish hue. But what does it mean to say that these colors were scattered? Well, first we need to talk a little bit about light, so follow me to my office. Each color of light that we can see with our eyes falls somewhere on this spectrum, but check this out. Colors closer to the red end have a longer wavelength, while colors closer to the purple end have a shorter wavelength. So the wavelength of the light is what determines its color, and we call these colors the visible spectrum, because they're visible to our human eyeballs. Side note, even though from space our sun looks white, it's actually emitting light of all colors of the visible spectrum, which when combined appears to us as the color white. Rayleigh scattering happens when a particle of light, or photon, comes from the sun, passes through the Earth's atmosphere, runs into an air molecule, and changes direction. Now the amount that it changes depends on its color, or wavelength, and the size of the air molecule that it runs into. So let's take a look at an example to better understand what this means. Our favorite blue photon has just left the sun and is headed for the Earth. As it passes through the atmosphere, it bumps into an air molecule which causes the photon to change direction. And because the photon's wavelength is this big and the size of the air molecule is this big, it changes directions by kind of a lot. But now check out what a red photon does. As it passes through the atmosphere, it too bumps into an air molecule and it too changes directions. But because the red photon's wavelength is this big and the air molecule is this big, it changes directions but not by very much. And this happens to all the colors of light. Photons that are closer to the blue end of the spectrum scatter more than photons closer to the red end. So when you look up at the sky, this is what's happening. The red and the yellow light doesn't scatter very much and comes nearly straight down, which is why when you look up at the sun, it appears yellow. Meanwhile, the rest of the sky is bathed in a sea of green and blue light that's been scattered in all directions, resulting in a diffuse pale blue color. And even though the sky turns a reddish orange color when the sun is low on the horizon, the same principles still apply. The only difference is that the light has to travel farther through the air before reaching your eyes. This causes the blue and green light to get scattered away pretty soon after entering the atmosphere, and so those colors don't make it as far as red and yellow, which are able to pass through more air before scattering too much. And if we zoom way out, we can see that this is the same reason the moon has a red tint during a lunar eclipse. The only color to make it all the way from the sun through a thick layer of the Earth's atmosphere and out the other side is red. And so, as the moon passes through the shadow of the Earth, it looks kinda red. So whether you're taking in a peaceful evening underscored by the soft glow of a red sky or enjoying the clear blue sky on a crisp spring day, remember, Google was originally called Backrub. I know that's unrelated, but it's kinda crazy, right? Like, what if that was still their name today? Seems kinda strange. I'd like to shout out my friends over at nosyuniverse.com who I collaborated with while making this video. They run a great blog with lots of cool, interesting articles being updated all the time. So if you like this video and this type of content, head over to nosyuniverse.com and learn something new today. Link in the description.